This PPT is going to deal with light sources and detectors. So when we looked at the fiber optic communication link, we first saw that there was a light source, a laser diode or an LED diode, and that is what is transmitting light into your cables. And at the other end you have a detector which is picking up the light, and then those signals are again restored and whatever. So we looked at the intermediate process, which is the fiber optic cable itself, in quite some detail. Now we'll spend some time looking at the light sources and detectors. So these are the properties that your light source should have. Compactness. It should process high modulation bandwidth, meaning it should be able to carry a lot of information within one beam. High output power, low dispersion, high degree of coherence. Coherence meaning I spoke about a range of wavelengths, right? So that range should be a very narrow one. The wavelength should not be spread all over the spectrum. That is high degree of coherence. Low threshold current, meaning the current which your light source itself is going to consume. It should not consume too much electricity. Operating wavelength should tally with the low loss, low dispersion windows. Yeah, we looked at those windows where attenuation is high, dispersion is high and all that, right? So the wavelength of your light should belong to a window where all these losses are low. Then direct modulation capability, meaning it should be capable of carrying analog or digital signals through light. Low chirp, high wavelength stability. Chirp is variations in frequency, just like our wavelength is spread over a range, so is our frequency. So when I say high degree of coherence, I mean that there should not be too much variance in the wavelength. Similarly, low chirp means that I don't want too much variation in my frequency either.